guys, welcome to the first ever Matt with Math video, a video where I explain some fun questions that I have discovered while working on math problems. In each video, I will explain a problem in a certain topic in math. For example, this problem we are going to discuss today is a problem related to geometry. The question is, the length of a common internal tangent to two circles is 7, and a common external tangent is 11. Compute the product of the radii of the two circles. As you can see here, I already have a little diagram drawn out to save time. I have labeled the centers of the circles O1 and O2, and the radius of the two circles R1 and R2. And these two circles are the same, and the distance between O1 and O2 are also the same. So first, we're going to work on the first one, where it's the external tangent. So you can see that the length of AC is equal to R1 minus R2. And then you can see that CB is equal to O1, O2. O2. And that, so the triangle ACB is a right triangle because any tangent to the circle center is always 90 degrees, and you can see that the 90 degrees is angle A. So that means CB is the right triangle's hypotenuse. So we can say the CB squared equals AC squared plus AB squared. Then we can replace AB, CB, and AC with the variables up there. We can say that CB equals O1, O2 squared, which equals to R1 minus R2 squared plus, because AB equals 11, it says that in the problem, 11 squared. Then you can expand this equation, which equals O1, O2 squared equals R1 squared plus R2 squared minus 2R1 R2 plus 121. So we just represented the distance between O1 and O2 with these variables R1, R2, and 121. Don't be afraid to when you see two different variables, because in the end these variables will cancel out in the second graph. Okay, so in the second graph, let me just move down here to get a good picture. You can see that there is a triangle O1, C, and O2. And we can see that the legs are O1, C, which equals to R1 plus R2, and the another leg is CO2, which is equal to AB, which A is the internal tangent, the point where the internal tangent touches the large circle, and B is the point where the internal tangent touches the smaller circle, and that equals to 7. So we can replace O1, O2, which is the hypotenuse, with R1 and R2 and 7 again with variables. So that will equal O1, O2 squared will equal to O1C squared plus CO2 squared, which will, and then, which will equal to O1, O2 squared equals to R1 plus R2 squared plus 7 squared. And that, if you open the parentheses, squared equals R1 squared plus R2 squared minus, plus 2R1 R2 plus 49. And you can see here in the two equations, this equation and this equation are both equal because they both equal O1, O2, the length from O1 to O2 squared. So that means you can write it as R1 squared plus R2 squared plus 2R1 R2 plus 49 equals, come back here for the second equation, it was R1 squared plus R2 squared plus minus, another mistake, 2R1 R2 plus 121. And then you can see that the R1 squared and R2 squared cancels out on both sides. And you're left with 4R1 R2 equals 121 minus 49. And because we're trying to find the product of the two radii, which is basically R1 times R2, you can see it's perfect because we already have R1, R2 here, so all we gotta do is divide by 4 on both sides, which is equal to R1, R2 equals 121 minus 49 over 4. And this equals 72 over 4, which equals to 18. And there we go. This is how to solve the problem which asks for the product of the two radii. So what we did, a brief recap of what we did is just basically we represented the radii as variables, and then we found and we used the tangent lengths, and we drew a triangle to find a common distance O1 to O2, and then we solved from there, eliminating the R1 squared and R2 squared. So in the future, I will be making more videos that will talk about more problems and more of the other topics in math, like algebra and like simple tricks. And yeah, so I guess I hope you like it, and I hope you learned something new. Goodbye.